So, hello everyone, my name is Suryaprakash, and in this video, I'll be demonstrating for SWE645 assignment 2, where I containerized a student web application using Docker and deployed it on Kubernetes with 3 replicas and established a complete CICD pipeline using Jenkins and GitHub. So, in this video, I'll demonstrate the complete setup and working deployment, walking through the AWS infrastructure, the Kubernetes cluster, the Jenkins pipeline, and the running application. So, let's begin with the AWS infrastructure. So, this is the AWS console. We'll navigate to the EC2 instances. Here in the EC2 instances, you can see an instance with Jenkins EKS and with an instance ID IOOE, and this is the instance ID running on Ubuntu server. Here you can see Linux platform is running on Linux, and here are my Elastic IPs. Yeah, here are my Elastic IPs. I have allocated the IP address 52.5.2.10 to 10.194, which is associated with my Jenkins K3 server instance. So this ensures that the IP address remains constant even if I stop the when if I stop and start the instance. So let's look at the security groups. So now let's look at the security. Here you can see the inbound rules. Here you can see the inbound rules right here. Let me go to the wizard, and here you can see the inbound rules. Here I have allocated the IP V4 SSH and port 22 and port 80 for HTTP and port 8080 for custom TCP for Jenkins server and port 30080 for the Kubernetes node port service. And these rules allows public access to the application and Jenkins while keeping the infrastructure secure. So moving on to the SSH connection through the PuTTY terminal. So let's connect to SSH through PuTTY terminal through the ppk file. Session, and here I need to enter the host name, that which is 1.2.52 at 52.5.210.194. If you apply that, yeah, click on open, and we connected to the Ubuntu. And after connected, so here we have connected with our EC2 instance, which is in AWS server. And here we'll firstly check whether the Docker is installed or not using the command docker dash dash version, and it shows the Docker version. And we'll also check the kubectl version is installed or not for managing the Kubernetes using the command kubectl version dash dash client. Here it shows the client version of the kubectl installed in our system. I mean EC2 for EC2. And we'll also check the K3's lightweighted Kubernetes distribution is active and running. So for that, we need to type the command sudo systemctl status of K3 status K3s. Here you can see all the K3s branches that are listed here, which are active and are running. And also we'll check Jenkins is also active and running, which is connected to 8080 port using the command sudo systemctl status Jenkins. I guess that's it. And sudo. So here you can see the Jenkins server is enabled and also running. And we'll exit from this. And coming to the Kubernetes cluster. So let me demonstrate the Kubernetes cluster configuration and the deployed application. So here you can see our Kubernetes nodes is in the ready state. We should need to check that using the command kubectl get nodes. It gives that the nodes are in ready state. And this single node K3 cluster gives full Kubernetes functionality. And by using the namespaces command, you can see that the namespaces in our cluster. The command to check the namespaces is kubectl get namespaces. Yeah, here you can see the namespaces in our cluster. You can notice the student survey namespace, which I created specifically for the application. And we also have one more command to see the 3 pods running in the student survey application, which mean kubectl get pods dash and student survey. So here you can see the 3 pods that are running for application of student survey application as required by the assignment. We have at least 3 pods running at all the times for high availability and load balancing. All these pods show the status running and one by one ready for serving, meaning they are healthy and serving the traffic. And also we have one more command to which shows that three desired replicas are ready. So we'll go to that command. Deployment and student survey. So here you can see that the deployment shows 3 by 3 desired replicas are ready, and Kubernetes automatically maintains this count. If your pod crashes, it will immediately create a replacement. And we had one more command, get svc dash n dash n student survey svc. Yeah. Mhm. So yeah, here our Kubernetes service, it is configured as node port 30080. The service load balances traffic across all the pods. And uh, let me describe one more command to show that uh, about more details, to see the pod details. So let's go through that command, which is kubectl describe and pod. And we need to enter the first pod name, which could be this student dash survey dash deployment dash 54F676C 747 dash 7 VWQB. This right? Student survey deployment 54F676C 747 VWQB. Yeah. Oh, it shows the student pod is not found. Mm. So yeah, and pod name and then dash n student survey. So let me describe this one of the pod to show more details. Here you can see it is using an Nginx server. Here, where it is. Yeah. Okay now. No, not much. I bet. So here you can see it is using the Nginx server from the Docker image, Suryaprakash 737 student server latest, which is running on the 80 port number 80. And we can also get the logs from one of the pods showing Nginx is running successfully by running the command kubectl logs. Then again, the first pod name of the first pod. I'll do one thing. I'll edit this command because it contains the name of the first pod. So kubectl logs and name of the first pod, and then yeah, dash and dash student survey and head dash 20. It gives the head first 20 logs of the pod. So yeah, here you can see the logs of the pod for 20 logs of the pod. And coming to the application demo. So now let's access the running application using our EC2 link. I mean the EC2 link of the which is deployed on Docker. I'll run the link in browser. Here I have the links. So this is the application link. I'll copy it and paste it in the browser and run it. So here you can see the application in your web browser. So this is the home page of the student server application. It can be accessible at this link. And this traffic is being load balanced across the 3 Kubernetes pods. And this application is a static HTML website using Nginx web server. So let me navigate to the survey form. So here is the student survey form with the fields for collecting student feedback. This includes validation and collects information like name, address, and email, and date of survey, and what students liked most in the university, and some more details. So let me quickly fill this and we'll try to submit this. Oh, sorry. City, Fairfax, State, Virginia, zip code 22051, telephone number, email address at gmail.com. Yeah, I'll simply copy this and I'll paste this because it takes a bit longer to type all these. First, let's try to submit without filling this last name column. I will check. So see how it is asking to fill the last name. So I'll fill this and I'll quickly submit this. So it's asking for this. Yeah, and I'll submit this. So here you can see the a dialog box confirming that that our response has been successfully recorded. And this form validates the inputs and submits successfully. So in real scenario, it would store the data for this demonstration. The focus is on the deployment infrastructure. So this application is running in 3 separate pods, all serving the same content, providing redundancy and scalability. So let's quickly go through the Jenkins. Let's demonstrate the Jenkins CICD pipeline using the uh, Jenkins link. I'll quickly copy this link and paste it in the browser. Here I already had the login details saved, so it automatically brought me to the dashboard. Here you can see the student server pipeline. So I'll click on this, and here you can see the logs, the build logs here. So build number 4 here you can see build number 4 was most recent successful build. Let me show you what this pipeline does. Let's configure. And here you can see that this pipeline is configured to pull code from the Git. I provided my GitHub link over here, and it uses the Jenkins in the repository, which defines 4 stages: check out from the Git, build Docker images, and push image to Docker Hub and deploy it on Kubernetes. And yeah, here is the console output from the last successful build. First, Jenkins checked out code from the GitHub, and then it builds the Docker image using the Docker file, and it pushed the image to Docker Hub with a build number tag. Here you can see the build number tag. And it finally applies the Kubernetes deployment and restart the pods. The entire process took about 60 seconds. Now let me demonstrate the automation by triggering a new build. So I'll click on the build now. I'll go back and click on the build now to start a new build. So here you can see a new build with the number 5 has been started. So let me click on this. So you can watch as Jenkins executed in real time. Checking out code, complete, building Docker images. This takes about 20 seconds, complete, and pushing to Docker Hub, complete, and deploying to Kubernetes. And once finished, that's it. We had completed this successfully. And this demonstrates that any code change I push the Git will automatically be build, containerize, and deploy Kubernetes without any manual intervention. And now I'll walk you through the Docker Hub also. Mm, Let me open it in a new tab. Oh, okay. Okay. So let me open it in a new tab. So yeah, let me open. I'll open this Docker Hub in a new tab. So here you can see the Docker Hub. Sign in. I should sign in with my details. So this is the Docker Hub repository for the student survey application page. And you can see the repository is public, allowing anyone to pull the image. There are multiple tags here representing different builds from Jenkins. You can look over here. There are multiple tags representing builds from Jenkins. And the latest tag is what we see here. You can see the latest tag. The latest tag is what Kubernetes pulls for deployment. Each number tag corresponds to a Jenkins build number, providing version history and availability to roll back if needed. And you can also see the size. Let me click on this. There you can see the size. This is approximately 3.62 MB based on the Nginx Alpha 9, which is a lightweight base image. So I'll quickly walk you through the Git repository also, where my code was pushed. So this is the Git repository. Here you can see all the HTML files, the index file, survey file, and error file. So and image SW file. And coming to the Docker file that defines how to build the container, and also Jenkins file defines CICD pipeline and K deployments. Says here, and K deployment.yaml files, it defines the Kubernetes resources. And you can also see the README file over here with complete documentation of our project, how it is implemented, and how should be used. And in Docker file, it starts with an Nginx Alpine server, contains our HTML files into the Nginx, all our HTML files, and exposes to port 80. And the Jenkins file with 4 stages of pipeline I showed earlier in Jenkins. And also the YAML file defines both the deployment with the 3 replicas. You can look over here, the 3 replicas and the service with node port configuration. Uh, and uh, and any commit to this repository triggers the Jenkins pipeline to rebuild and redeploy automatically. And that's all about the project. And thank you for. So I'll quickly conclude this. So in summary, I have successfully containerized the student server application using Docker, deployed it on Kubernetes with cluster with the 3 replicas for high availability, and established a complete CI/CD pipeline using GitHub and Jenkins, and deployed everything on AWS EC2 infrastructure, and made the application publicly available at this IP address, at this URL. Jeez. which is this HTTP 52.5.210.194 on 3W8 port. And all the source code files, configuration files, and documentation are included in the submission package, which could be submitted in Canvas. So that's all about my project. Thank you for being patient with me and listening to the project.